everybody. Today we'll be working on section 1.7, linear inequalities. And our objectives will be to solve linear inequalities with one variable, solving three-part inequalities with one variable, solving compound inequalities in one variable, and using inequalities to solve application problems. So let's first talk about inequalities. So when we talk about inequalities, we mean something is not equal to. So, well, it could be, but it could be greater than or equal, or less than or equal, or less than or greater than. So those are called inequalities. So the first thing you want to do, you want to graph what you can. So we're going to be doing a few different things with inequalities, but always you want to use a number line to graph not only your solutions, but your work. It will make it a lot easier. And then there's going to be two different ways that we're going to learn how to write the solution. One of them is called set builder notation, which is this. And basically, let me explain what each thing means. Anytime you have these curly braces, it means you have a set. So you could just read it as the set of. Okay, so you see those curly braces, it means set of. And of course, then the X means set of X. What we're doing is saying we're going to start with every single possible number of X. And then after that line, we're going to describe the restrictions we're going to put on that X. Okay, so this says the set of with the braces, X means all values. And this line, you can read it as such that. So now I'm going to read this as the set of all X such that X is less than or equal to 4. This graph right here on the number line represents X is less than or equal to 4. If it was just X is less than 4, so if we wanted to just do X is less than 4, and I'll write it over here in red, X such that X is less than 4, then the difference would only be that instead of a closed circle there, we have an open circle, and it still would go in the same direction. So that would basically be the less than instead of the less than or equal. And then we're going to learn how to write the solution in interval notation. This means from negative infinity, we always go from the smallest to the biggest. So the smallest here is negative infinity because it's less than 4, so it keeps going on infinitely to the left of that dot, and it goes up to 4, and this means including 4. And we're including 4 because it says less than or equal, and so since 4 is equal, we include it. If we were doing the less than, so if I just wanted X is less than 4, I would go from negative infinity to 4, but I would put parentheses, meaning 4 is not included. Okay. I guess this is the question that they started with to find the answer, but we'll go through some other methods. Okay, so definition, a linear inequality in one variable is an inequality that can be written in the form ax plus b is less than c, where a, b, and c are real numbers, and a is not equal to 0. Of course, if a is equal to 0, then we don't have an x and there's nothing to solve. So it says the inequality symbol less than in the definition and the following properties can be replaced with. So basically, I think what they're saying is that as long as in this form, in some way, for example, let me see what I want to say. Here, I can say like this. Let's do this. So we can say 2 is less than 3. Okay. I'm just giving you an example, not a linear example. Notice this has no x in it. But I wanted to show you, some people have a hard time remembering which way things go or what these different things mean. So the way I always think about it is the small side of the symbol is going to the smaller side, and the bigger side of the symbol, and when I say that, I mean like that side is bigger, it opens, goes to the larger number. So I can take this same exact thing and I could say 3 is still greater than 2. Here it says 2 is less than 3. The one in green says 3 is greater than 2. Notice still the larger size is pointing to the larger size of the symbol is pointing to the larger number. And then this one just means it's less than or greater than, but it also can equal that number. So 3 is less than or equal to 3. That's a true statement. This is true. 3 is less than 3 is false. 3 is not less than 3. It's equal to 3. So hopefully that explains a little bit more about inequalities. Let's solve a couple. So it says solve this inequality. Basically, all you're really doing is solving it like it's an equal sign. The only difference with inequality, and this is really important. So for inequalities, there's one big difference. If I multiply or divide by a negative number, I flip the inequality sign. Sign. Okay, this is really, really important because otherwise you're going to get the wrong answer. So other than that, we just pretend it's an equal sign. So what would I do first? Well, let me rewrite it here. Minus 9x minus 3 is greater than or equal to 7 minus 4x. So, it depends on what you like to do. I'll just get the x's to begin with over to the left. So I'll add 4x to both sides. And I get minus 5x minus 3 is greater than or equal to 7, right? And then I can add 3 to both sides, which gives me minus 5x is greater than or equal to 10. Now, notice the last thing I'm going to do is I'm going to divide both sides by negative 5. So for inequalities, if I multiply or divide by a negative number, here I'm dividing by a negative number, I have to flip the inequality. And let me show you what that means. So these cancel and I get x, and I get x is less than or equal to negative 2. So notice I flipped the sign, okay? If I don't flip it, I would have greater than or equal, and that would not be true. So now it says graph the solution on a number line. So let's do that. So here's negative 2 over here. And this will be 1, 2, and so on. And less than or equal negative 2. So I would put a closed circle because we're including 2. And then since it's less than, it has to go to the left here. So this would be the graph of x is less than or equal to negative 2. And then the last thing it says is write the answer in interval notation. Interval notation, we start with the smallest number. So this is going all the way to negative infinity. So we start negative infinity. And then I put comma. And where does it go? What's the biggest number that it is negative 2. Okay. And then I just have to decide what my ends are. Are they parentheses or are they square brackets? Infinity and negative infinity are always parentheses. So you don't have, as long as you have a negative infinity or a positive infinity, it always has a parentheses because it's not actually a number that we can plot on the number line, right? So we just say it just goes on forever. Now, -2 here, it says less than or equal, which means I have to include -2 because it can equal -2, which means I need a close bracket. If it was just x is less than -2, then that would be a parenthesis. So that's basically how we solve these problems. This looks a little different. Here we have an inequality basically that says the middle part, which is 2 minus 4x over 3, is between -2 and 5. So that inequality, that expression in the middle is between -2 and 5. It includes -2, but not 5, okay? And I'll show you as we go what that means. So we start off with -2 is less than or equal to 2 minus 4x over 3, which is less than 5. Now, again, the same thing that we said before about if we multiply or divide by a negative number, we have to flip the inequalities. Here we're doing all three pieces at once. This is a three-part inequality. So the first thing I want to do whenever I solve something that has a denominator is I want to, and it's just a 3, so I don't have to worry about what x equals, because we don't have to worry about a 0 in the denominator here because it is a 3. So first thing I can do is I can multiply all of it by 3, which means I can multiply this piece by 3, and this piece by 3, and this piece by 3. And when I do that, here I get -6, and it's +3, so I don't have to flip the inequality. So it's less than or equal. And then this 3 will cancel with this 3, and I'll get 2 minus 4x is less than 5 times, that should be a 3, not a 5. Sorry about that. So less than 15, okay? And then I want to leave the x in the middle because I'm trying to solve for x here. So I'm going to subtract 2 from every section. So I have -8 is less than or equal to, this cancels, -4x, which is less than 13. Okay. And then the last step, what would the last step be? Well, I want to get x by itself here, so I divide everything by -4. Aha, so now I did multiply or divide, actually divided by a negative number. So what we're going to do first is we're going to say -8 over -4 is 2. And then I'm going to flip the inequality signs, both of them. This cancels, so I get x here in the middle. And then I have to flip this, and this is -13 over 4. Okay, so that's my solution. Then it says graph the solution on a number line. So let's get a new page because I am out of space. And now what I'm going to do is I'm going to actually flip it around. So I'm going to say -13 over 4. So here it says x is greater than that. So that means this is less than x, right? So I can, as long as I turn everything, and remember what I said, the larger side of the inequality is pointing to the larger number, which is true. And then this would be less than or equal to 2. So now let's put it on a number line first. So here's 0, 1, 2, and 13/4. Well, 13 divided by 4 would be 3, because 12 divided by 4 is 3. And so it's a little more than 3, right? -3. So let's 1, 2, 3, 4. So this is -3 and -4. And we'll say that, so -13/4 is going to be the same as -3 And then, so it would be negative. If I turn this into a mixed number, what I'm doing is dividing. So basically I'm dividing 13 divided by 4, which gives me 3. 3 times 4 is 12 with a remainder of 1. So I have negative 3 1/4. So it's a little further over. So I'll say this is negative 13/4 right there, right? And that is an open circle. And I'm going to put it above because if I put it on a line, it's harder to read. But you can put it right on the line when you do it on your homework. Now it's an open circle because it doesn't include negative 13/4. And that's the smallest number. And it's going to go all the way to 2. And it does include 2. So basically, that is my solution. That red line is my solution graphed on the number line. And then it says, write the solution in set builder notation. So set builder notation is the one where we're building a set. Remember, first off, I have my braces, my curly braces, which means set of all x such that x, and basically we're just going to write this part right here. So x is greater than minus 13/4 and also less than 2, less than or equal to 2. And that would be my set builder notation. Okay, so hopefully that is clear.